Hello students, I Professor Pote RK welcomes all of you for the online lecture series of design of steel structure. In today's lecture, we will be learn regarding the design of compression member. So, what does mean by a compression member first? A member which is subjected to the two equal and opposite compressive forces applied at each end. It is a straight member supported at each end. So this is our structural element, that is the compression member. When the load is applied on it, it gets reduced by the length delta L. Then requirements for the ideal compression member. These are the least possibilities and these are some standard requirement for the compression member. First one, it should be perfectly straight. Second, it is load acts uniformly over the cross section. Third, there should be no crookedness. Then no imperfections. And last is load should act in axial direction. Then classification of the compression member. The first classification is column, stanchions or post supports floor, girder and subjected to the heavy loading. Then second is strut for the small span, light load and truss members. Then depending upon the types of failure, long buckling, short crushing, intermediate crushing and yielding. Next, for design of any compression member, we must know the effective length of that member. So, what is the definition of effective length of the compression member? It is nothing but it is the distance between the point of contraflexure calculated using support end condition. K factor is calculated from table number 10, page number 45, and hence the effective length of the member is equal to K into L. Then there are three types of the supports. Depending upon these supports, there are three types of reaction, and then we will study the table from the table how to calculate the effective length for each and every condition. Our first support is the roller support. Here this roller support is subjected to the rotation and translation. This is the roller support. Here the reaction is 1. Second one is the pin support. Here pin support is nothing but the hinge support. It has two reaction in the vertical as well as in the horizontal direction. Third one is the fixed support. Fixed support has three types of reaction, that is one movement and two reactions in the two reactions, out of which one is in the horizontal direction and second one is in the vertical direction. Then from the table we will learn how to calculate the effective length for each and every condition. There are two in the table. You will observe there are two table in the two columns given. The first one is for boundary condition, second one is the diagram, and last one it is the effective length for that condition. Further, the boundary condition column is divided into again two parts. It is the first one is for the one end and second column is for the other end. Then again the end column is divided into the translation and rotation respectively. Suppose I am going to study our first case, that one end of the column is restrained in rotation as well as in translation, and at the other end the column is free for translation and free for rotation. Means Here the column at the one end it is fixed one. That time the effective length is twice L. Similarly, if the column end is free for translation at both the side and restrained in rotation at both the sides, that time the effective length is twice L. Then the third case, that is when the column is restrained in translation at both the side and free for the rotation at both the ends, that time the effective length is 1 into L. The next case is that column is restrained against rotation and translation at one end as well as rotation at the other end, only free for translation at the other end. That time the effective length is taken as 1.2 L. Next case is when the column is restrained for translation and rotation at one end as well as translation at the other end and just free for rotation at the other end. That time the effective length is taken as 0.8 L. Next, whenever at one end and other end the column is restrained against rotation and translation, means all the four means, that is rotation and translation, are restrained, that time the column has effective length of 0.65 L. In this way we calculate the effective length of a compression member. Next is the slenderness ratio. The longer the compression member becomes for the same cross section, greater becomes its tendency to buckle and smaller capacity to bear the load. This tendency of buckling is measured by the slenderness ratio. The ratio of effective length to the appropriate radius of gyration is called as the slenderness ratio. It is given by the formula KL upon R minimum, where R minimum is calculated from steel table or noted from the steel table, and KL is calculations are done as shown in the previous slide. L is the unsupported length, and in order to calculate the lambda maximum, R should be taken as minimum. Therefore, lambda max formula is modified as lambda maximum is equals to KL upon R minimum, and R minimum is equals to under root of I by A. Then for maximum slenderness ratio, refer table number 3, page number 20 of IS 800 2007. Then types of the buckling in the column. The first one is the flexure buckling, the second one is the torsional buckling, and third one is the flexural torsional buckling. Flexure buckling, here it is the deflection caused by bending or the flexure about the axis corresponding to the largest slenderness ratio. Then the torsional buckling, it is the twisting of a thin wall member rather than the bending. Then next is the flexural torsional buckling. The member bends and twists simultaneously, occurring only with the unsymmetrical sections, that is the channel section, T section and angle section. Here the flexural buckling can be explained by diagram number 1. The torsion buckling as well as that is the flexural torsional buckling can be explained in the diagram number 2. You may observe that the member is being buckled in the flexure, and here the member is buckling in the flexure as well as in the torsion. Then buckling classification as per the geometry of the cross section. So there are 4 types of factor which affect the buckling classification. The first one is the shape of the cross section. Due to the arrangements of cross section with different elements, same cross section area and the slenderness ratio of different member behave differently. Here circular section will be behaving differently, square section will be behaving differently, angle section will be behaving differently, and eye section will be behaving differently. Then the presence of residual stresses. The stresses develop due to the differential cooling after hot rolled process. Dear students, we know that all the steel structural elements are produced by using the hot rolled process. Here, due to this hot rolled process, there are some residual stresses left due to the heating and cooling action. Where if you observe the diagram, the red part is nothing but the residual stresses left in the column, and these stresses can be analyzed by using the finite element method, and because of these residual stresses the buckling classification is changing. Then we have the effect of bowing of the bow of the member, that it is nothing but the imperfections and curve length reduces the strength of the member. If you see in the diagram which I am highlighting, here you will be observing the first effect of bowing is camber effect. The dotted element is a straight member, whereas the member is buckling in one direction. Hence this effect is called as an camber bow. Then a normal bow, if the dotted element is a straight element, but after when the element is straight for at some length, thereafter it is bent in a vertical direction, that is nothing but the bowing of a member. Then twisting. Similarly, the some part of a element twist by some amount or some angle, small minute angle, which also hampers the buckling classification of the section. The fourth one is the effect of eccentricity of a load. The load is acting on the another CG of a load. Here the CG is being shifted due to the loading, and hence it changes the buckling classification of the section. Then Euler's buckling curve for ideal column. Here is a small derivation for KL upon R minimum is equals to 89, because for a very less value of 89, column act as a short column. If it is greater than 89, Euler's formula it is applicable for the long column. Hence, for calculation of Euler's buckling load, P is equals to pi square EI upon KL square. Here we are substituting I is equals to AR square in the given formula. That time we get PE is equals to pi square EAR square upon KL square, as FA is equals to PE upon A. Therefore, FA is equals to pi square E upon KL upon R square. Therefore, substituting value of E is equals to 2 into 10 raised to 5 MPa and FA is equals to 250 MPa. We get the value of KL upon R minimum as a 89. Hence, if KL upon R minimum is 89, the column behave as an short column, and if not, it will be behaving as an long column. Then European column curvature ECC. As the Euler buckling curve is applicable for only ideal column, some European researchers have made results based upon the experiments and proposed different buckling curves corresponding to the 4 classification of the section. These curves are called as ECC. These are the ECC curves. The design compressive stress cannot be Fy, and reduction factor in Fy, that is capital X, and difficult to quantify. The value of FCD for different class of cross section are given in table number 9A, 9B, 9C and 9D of page number of IS 800 2007, and the imperfection factor alpha depends upon the buckling classification of the section, that is A, B, C and D. Here FCD is equals to Fy upon gamma m0 upon phi plus under into bracket phi square minus lambda square into bracket raised to 0.5, which is equals to x or xi Fy upon gamma m0, and it should be less than Fy upon gamma m0, where phi is equals to 0.5 plus into bracket 1 plus alpha into bracket lambda minus 0.2 plus lambda square, and lambda is equals to non-dimensional effective slenderness ratio, which is equals to Fy upon FCC, and it is equals to under root of Fy into bracket KL upon R square upon pi square, and FCC is equals to Euler's buckling stresses, and it is calculated by the formula pi square E upon KL upon R square. Hence this value of FCC is substituted in the above formula and the value is been modified. Buckling class of the section. From the table number 10 of page number 44, we get the idea regarding the buckling classification of the section. From the bottom, if you observe the channel section, angle section, T section and other solid section, the buckling class of section is C. Always remember this thing. For the built up member also, the buckling class of the section is C. So this buckling class hampers the imperfection factor. Then cross section, I section, very important section to be get classified. Here this is the y axis, this is the x axis, this is the z axis. This is the I section. Now dear students, the first column shows us the cross section, second column shows us the limits, third column shows us the buckling about the axis, fourth shows us the buckling classes of the section. If our h upon bf value is 1.2, here h upon bf, here h is the total depth, bf is the flange width, t is the thickness of the web, tf is the thickness of the flange. Then if this ratio of h upon bf, if this ratio of h upon bf is greater than 1.2 and the thickness of the flange is less than 40 mm, that time the buckling may be about z axis or y axis. The second case is if this tf value is greater than 40 and less than 100 mm, that time the buckling will be also about z or y axis. Now depending upon the r minimum, value of r minimum, the further classification is done in the x. If my r minimum rxx value is less than ryy value, that time my buckling class will be A, and if my ryy value is greater than rxx value, that time my buckling class will be B, and similar will be the further classification of the section. Then design of a strut. A compression member usually adopted for roof truss for a bracing and subjected to the compressive force is called as an strut. These are the smaller in the length and subjected to the light loading. This is a small diagram of a strut. Here the design compressive strength of a member PD is equals to AE into FCD. The effective length for a truss member shall be taken as 0.7 to 1 time of the distance between the intersection. The effective length for the double and discontinuous strut back to back on a gusset plate shall be taken as 0.7 to 0.85 times the distance between the intersection. And the last one is the angle section transferring the compressive force may be eccentrically or concentrically loaded. Now, whenever the angle sections are loaded through one leg, the flexural torsional buckling strength of a single angle loaded in the compression through one of its leg may be evaluated using the equivalent slenderness ratio lambda e as given below. Lambda e is equals to under root of k1 plus k2 into lambda vv square plus k3 into lambda phi square, where k1, k2 and k3 are the constant which are depending upon the n conditions as shown in the table number 2, and lambda vv is equals to 1 upon r vv upon epsilon into bracket pi square epsilon upon 250, and lambda phi is equals to b1 plus b2 upon twice t upon epsilon into under root of pi square e upon 250. Note, for a strut design member, assume FCD is equals to 90 MPa to 80 MPa for a single angle and 100 to 110 MPa for the double angle. We will study here, dear student, how to calculate this K1, K2 and K3. Suppose I assume that my number of bolts for the connection is 1 and my gusset plate is fixed in position. That time the value of K1 is equals to 0.75, K2 is equals to 0.35, K2 is equals to 0.35 and K3 is 20. If I assume my number of bolts are 2 or greater than 2 and the member is hinge member, that time K1 is equals to 0.7, K2 is equals to 0.6 and K3 is equals to 5. Dear students, this was what about the design of compression member. In next lecture we will study the design for the compression member in the form of numerical. Till then, keep watching and subscribe the channel. Thank you.